Back, folks, for a more discussion on scale. This time we're going to talk specifically about scale factors with the focus on determining a relationship scale factor, getting bigger, getting smaller, and by how much, what is the scale factor? And then we're going to use it to construct similar figures. So just a reminder that scale can be reduced or enlarged. And so I'm going to leave you with this question. I wonder if you can fill in the blank. What would be the relationship of the scale factor to 1? Would it be exactly 1? Would it be more than 1? Would it be less than 1? I want you to continue considering that as you consider reducing and enlarging objects with a scale factor. Now, the scale factor is the ratio or length on a scale drawing. I'm not sure why it says or length. That corresponds with the length of the real one. Maybe that should say ratio of the length on a scale drawing or model to the corresponding relationship on the real. Now, both quantities must have the same unit. That is crucial. So let's say you have 1 inch is 2 feet. 1 inch on the model is going to be 2 feet in real life. How do we change that? Well, think about writing that as a ratio and then changing it to both feet or both inches. In this case, I'm going to choose to change it to inches. All right, 2 feet is the same as 24 inches. I'm not changing the relationship. I'm just rewriting it, representing it in a different way. And so now you have a relationship of 1 to 4, or excuse me, 1 to 24. Notice there are no units on this. So the unit is only, well, the unit's used when you're doing the real problem. 1/24 is the relationship of the model to the actual object. Now, if you look at it the other way, if you start with the model and change it to the real thing, then you would say that the relationship, the scale factor, is 24. So remember that question I'm asking you. Should that scale factor be exactly 1 whole, more than a whole, or less than a whole? It kind of depends on which direction you're going, but I want you to keep that in mind through the whole, through this whole video. All right, let's say when we're looking at a scale factor, we have a model sailboat. Scale factor is 1 inch to 6 feet. Now, first thing we can do, I'm actually going to do this once and only once using both directions. But if you recall from the last video, almost always we put the actual or real dimension down below. But does it matter is an interesting question. So let me go ahead and write inches to inches. 1 inch doesn't change, but look, this is supposed to be 6 feet. Okay, so 6 feet times 12 inches per foot, that'd be 72, which means the ratio is 1 to 72. Or yes, you could write it with the fractional bar in between. Now, let's look at it the other way. Let's say we change, oh, wait, that's not what I meant. We still have 1 inch to 6 feet, but let's say we want to change it both to feet instead of both to inches. 6 feet doesn't change. Okay, 1 inch is the same as how many feet? Well, I can't say feet plural. 1 inch is a portion of a foot. 1 inch, as a matter of fact, is 1/12. But consider how we divide and simplify complex fractions. We're going to change this. Instead of 1/12 divided by 6 wholes, 1/12 times the multiplicative inverse. Oh, look, it's the same thing. So I guess the question that I would leave you with is, if it doesn't matter, which one made it easier? And most of you are going to say choose the smaller units, because then you don't have this mess of complex fractions. But students with the strongest skills could show either direction, that the ratio, the scale factor, is 1 to 72. All right, here we go. Scale factor of a model sports car, 10 centimeters to 3 meters. Let's go ahead and write the units as always. 10 centimeters is related to 3 meters. Let's change this both. Now we could choose both to change to meters or both to change to centimeters, but most of us will choose the smaller unit to avoid the complex fraction. 3 meters, remember that each meter is 100 centimeters. Now, while that's an okay ratio, I do believe you can see that we can reduce by 10 to make a ratio of 1 to 30. So the ratio of the model to the actual sports car should be written as 1 to 30. All right, first find the scale factor, then find the length of the model. Scale factor here, 2 inches to 15 feet, 2 inches to 15 feet. Let's go ahead and change them both to inches, shall we? 2 inches is, well, still 2 inches, 15 feet, 15 times 12. 180. But naturally we'll want to reduce that, so let's go ahead and divide by 2, reduce by 2, and we find a ratio of 1 to 90. Now, I could use the 1 to 90 to find the actual length, but it's kind of messy. So instead, I believe what I will do, as we've done previously, is I'm going to set up a ratio with the different units. I'm going to look at the ratio that we know. 2 inches is the same as 15 feet of the real plane. I'm going to look at the quantity that we know, the 87-foot length, and then I'm going to set up, wouldn't you know, 15 times x, 2 times 87. And if we were to divide 174 by 15, running out of a little space here, my apologies, you would find it to be 11 6/10 inches, which, guess what? Once you find this in feet, it would be the same as 11 6/10. Just kind of looks a little bit uglier. 87/90 is feet of a foot, excuse me. Almost a whole foot, which kind of makes reasonable sense when you look at the answer of 11 6/10 inches. So scale factor is really a number that you can multiply. Some would argue divide as well, but I choose to use the word multiply. And it's going to describe either an increase or decrease. Now, remember what I said? Comparing to a whole. Because the scale factor is larger than a whole, what happens to this object? It is enlarged. Meanwhile, if the scale factor is smaller than a whole, what happens to the final object? It is reduced. So, how many times bigger is the blue shape? Now, I will invite you to always compare the new to the old. But let's say somebody messes up. Let's say instead of doing 10 to 5, they do 5 to 10. Instead of 4 to 8, they do 8 to 4. And they get a scale factor. Instead of 2 wholes, they get 1/2. But take a look at this. Is 5 times a half the same as 10? Or 4 times a half the same as 8? The answer is no. So even if you accidentally do the multiplicative inverse, you can say, well, wait a second. This blue new shape is getting enlarged, and therefore the scale factor must be greater than 1. So in this case, scale factor is 2. 5 times 2 is 10. And 4 times 2 is 8. Look at this one. If the blue shape is converted from large to small, what would the scale factor be? Some of you can already see, if you compare the new to the old, the 2 to the 6 or the 3 to the 9, in both cases, the scale factor is 1/3, which, by the way, makes sense, because since it's being reduced, that scale factor should be smaller than 1. And even if you made a mistake, if you accidentally said it's 3, you can stop yourself and say, wait a second, 6 times 3 is not 2. So that would tell you that something's up. Scale factor in this case is 1 to 3. Notice I don't say 1/3, 1 to 3. All right, pause the video. Come on back when you're ready. So in this case, check it. Is 7 times 3 21? Yes. Is 5 times 3 15? Yes. Notice also, because this is being enlarged, the scale factor is larger than 1. So that's what we have, folks. Now on to some practice. See ya.